Welcome back to another one of my integration examples videos where I basically go through 3 examples. Each one of these episodes will become increasingly harder, or I'll add different techniques and different ways of solving problems. Okay, so let's just start with example 1. Example 1, we have a function that equals square root of x on 3 plus 1 on x. Let's find the integral of both sides. Integral of x on 3 plus 1 on x dx, and I put a capital F to show that this is the integral. So we're going to separate these, and what I'm going to do is bring the constant out in 2 steps. So I'm going to bring out the 1 over 3, and so it's just going to be square root of x dx plus the integral of 1 on x dx. So you should know by now that the square root of x is the same as x to the power of 1 on 2, and 1 on x is the same as x to the power of negative 1. So this is what we're going to use. So 1 on 3, let's find the integral of square root of x. Doing the power rule, we add 1 to the power and we divide by the new power. So it'll be x. What's 1 plus a half? 3 on 2. Divide by the new power, which is 3 on 2, which will equal plus c, not equal, I'm going to talk about. And then we're going to add the integral of 1 on x. We know that the derivative of ln of x is 1 on x, therefore the integral of 1 on x is ln x plus c. Okay, I'm going to call this C1 and C2. So they're different, because they may be different, they may not be different, but we don't know. Okay, so I'm going to multiply this in, and I'm also going to, because we have a fraction on the bottom of a fraction, you basically flip it and multiply it back in. So think of it as this will now become 1 over 3 multiplied by 2 on 3 multiplied by x to the power of 3 over 2. Multiplying by the reciprocal. So we basically bring out the fraction, flip it, and then multiply it back in, which is what this is. 3 on 2 on the bottom, now it's 2 on 3 and multiply it onto it. And then we're going to have plus C1 on 3, because we've got to multiply the 1 on 3 onto the C1. And then we just add the ln of x and then the c subscript 2. This will equal, we've got 3 multiplied by 3, that's 9, so it'll be 2x to the power of 3 on 2 all over 9 plus ln of x. And I'm going to say that h equals C1 on 3 plus C2. Therefore I can just write plus h, and because I've written that, this h will include this and this. And there is our answer. Okay. Now I'm going to do another example. The second example, which is f of x equals x bracket x cubed minus 4 to the power of 2, or squared. Now I'm just going to expand it out, because that's the easiest way for me to do it. Doing any other integration methods would just be a pain for me. So I've already expanded this out, and it looks like 6 x to the power of 6 minus 8 x to the power of 3 plus 16. And then we multiply the x in and we get x to the power of 7 minus 8x to the power of 4 plus 16 to the power, 16 multiplied by x. Now we're going to find the integral. we use a capital F. I'm going to find the integral of each one separately. I'm not going to do it slow like the last one. I'm just going to write it out. So the integral of 7 to the x to the power of 7 is x to the power of 8 on 8, because you add 1 to the power then divide by the new power, plus c, 1, minus, you have 8x to the power of 4, so you add 1 to the power and divide by the new power. So you add 1, which is 5, divide by the new power, which is 5, plus 16x, add 1 to the power, which is 2, and divide by the new power, which is 2. And, I forgot, here we also have a plus c, and here we have a plus c. So I use the subscripts 1, 2, and 3. Okay? And just like before, I'm going to say, let's say, D equals C1 plus C2 plus C3, which means that I can now write x to the power of 8 on 8 minus 8x to the power of 5 on 5 plus, well, this is 16 divided by 2, which is going to be 8, so it's just going to be 8x squared plus d, because instead of writing all these constants, I can just write it with one constant, which equals all of these added together. Okay, and that is our integral. Okay, so example 3, which is going to be fx equals square root of x squared plus 2x plus 2. Okay, so what I'm going to do here, we're going to first write out the integral. Okay, I'm going to use integration by substitution. So I'm going to sub u in for the square root of x, or it's equals the same as x to the power of a half. Okay? And so derivative of u with respect to x, derivative of x to the power of a half is 1 on 2 square root of x. And isolate dx on its own, because we need a dx on its own so we can multiply it in here. And that will equal du on 1 on 2 square root of x, or that will equal 2 square root of x du. Okay. Now what I'm going to do is I'm going to rewrite it. So we have x square root of x is now u, and inside x squared, we can write that as x to the power of 4, because it's x to the power of a half. So think of it as if we had u to the power of 4, that's the same as having x to the power of 2, because this would be x to the, this is essentially 4 square roots, which would be the same as x to the power of 2 plus 2 u squared, because we have 1x. If we have u multiplied by u, that's a square root multiplied by a square root of x, which will just equal x. And then we just have 2 tacked on the end. And then just where we had dx, we sub in this, which will be 2. And I'm going to sub in, because there's a square root of x, I'm going to use u, and then we have du. Okay? So basically I've subbed in a u everywhere there was a square root. But if we have x squared, that's the same as u to the power of 4, because it's, if we have x to the power of a half, if we have x to the power of a half, and then we have that to the power of 4, that 4 will come in and it'll be the same as x to the power of 4 on 2, which is the same as x to the power of 2. Okay? That's how x squared equals u to the power of 4. Okay? Now, what I'm going to do is bring the 2 out the front because it's a constant. You have 2 integral u squared u to the power of 4 plus 2u squared plus 2 du. And I'm going to expand the brackets. So u to the power of 2 multiplied by u to the power of 4 is u to the power of 6 plus u to the power of 2 multiplied by 2u to the power of 2 is 2u to the power of 4, and u to the power of 2 multiplied by 2 is just 2u to the power of 2 du. Now we're going to find the integral of each one. So that's going to be u to the power of 6. It's going to be add 1 to the power, which will make it 7, and divide by the new power, and then plus c. And then we're going to have plus 2. We're going to add 1 to the power, so it'll be to the power of 5, and divide by the new power. Then plus c. Alright, we'll make it g, plus g. And then plus, the same for this, add 1 to the power, it'll be 2u to the power of 3, divided by 3, and I'm going to have plus h. Now I'm going to multiply the 2 throughout, and we'll end up with 2u to the power of 7 on 7 plus 4u to the power of 5 on 5 plus 4u to the power of 3 on 3 plus, and I'm just going to say over here, let's say w because we can, equals c plus g plus h. And then we could just say plus w. Okay, now what we're going to do is we're going to sub in the u's, and because a u is the same as x to the power of a half, that will look like x to the power of 7 on 2 on 7 plus 4x to the power of 5 on 2 on 5 plus 4x to the power of 3 on 2 on 3 plus w. Okay, and the reason I did this is because if we had x to the power of a half, just like here before, if we had x to the power of a half and then to the power of a number, like over here we have it to the power of 7, that's the same as multiplying that on. So it would be x to the power of a half to the power of 4 is the same as x to the power of 4 on 2. Therefore, x to the power of a half to the power of 7 is the same as x to the power of 7 on 2. And that's why I've wrote this. And that there is the answer. So I hope you enjoyed this video, and I hope you learned something, and have a good day.